Functions. Functions are everywhere around us. You can attend a function. You can use functions in computer programming. And then there are, of course, mathematical functions. But really, what is a function? A function is simply just a rule for pairing off objects from one set to objects in another. In math, it might look something like this. More specifically, you probably remember hearing the words, each input of a function must have one and only one output. For example, suppose your rule pairs the number 1 with 2. If this rule is going to be a function, it cannot also pair 1 with 3, because the input 1 has 2 different outputs, 2 and 3. In this example, suppose that the number 1 gets paired up with 2, creating the ordered pair 1, 2. Now, if the same rule takes 4 and also pairs it up with 2, this is okay. This is a function because it doesn't matter if the same output gets used. The rule is just that each input must have only one output. 1 has an output of 2, and 4 has an output of 2. They each only have 1, and it does not matter that they are the same. Now, before we move on and talk about topics like domain and range, it's important that you remember how to use interval notation. So I've provided a review sheet of how to use interval notation properly. The important thing to remember is that when you want to include a value in your interval on a number line that's represented by a closed dot, and in interval notation that becomes a square bracket. When you want to exclude a value from an interval, on a number line we use an open circle, and in interval notation next to that number we use a round parenthesis. Please refer to the interval notation review sheet that is posted in the course module for more details. Now I'm going to take you through some of the exercises similar to the homework problems you'll be doing in my math lab. Alright, so here's the first question we're going to begin with. We're asked to evaluate a function f of x equals 4x plus 4 at the given values of the independent variable and simplify. Alright, the question we're going to start with says evaluate the function f of x equals 4x plus 4 at the given values of the independent variable and simplify. The independent variable that they're talking about is the input for the function. It's the x. In A, that's the -2. In B, the input is x plus 5, and in C, the input is -x. Well, to evaluate f of -2, for part A, I'm going to come right over here. If our rule is that each input corresponds to an output of 4 times the input plus 4, if my input is -2, notice I'm substituting the -2 for the x. I do the same thing on the right-hand side. And then I do the arithmetic, and I will arrive at an answer of -4. And that's as simplified as that is going to get. All right, for part B, in this case, my input is this whole thing x plus 5. So to clarify a little bit with some color, this is the input, and I need to put it where the input goes. Now, when I say put it where the input goes, I mean in place of the x that's already there, you put this new input. You're not multiplying them, you're not adding them, you are literally just erasing the x that's in the original function and inputting your input. And notice how I'm careful to put it into parentheses to indicate that all of this is the input. Now, in this case, when it says simplify your answer, you would be expected to continue. You do some distributive property here, distributing the 4 only to what's inside the parentheses. So 4 times x is 4x, 4 times 5 is 20. You bring down the plus 4, and you have some like terms you can combine. So your final answer would be 4x plus 24. All right, and last example here. For part C, we have f of -x. Okay, so in this case, my input is -x. So once again, I'm going to kick out the x that's in the original function. I'm going to substitute my input, and again, I'm going to keep it in parentheses to make sure that I'm careful with my signs. And now I'm going to do the simplifications. So 4 times negative x would be a negative 4x, and bring down the plus 4, and that's my final answer for C. Now we're on to question 2. Question 2 has 5 parts. Use the graph to determine the function's domain, the function's range, the x-intercepts, if any, the y-intercept, if any, and the function values indicated below. Part A, what is the domain? So the domain is the set of all inputs for this function that's pictured here. In other words, it's the set of all x values that the function takes on. In order to determine this, you are going to look from here, which is the lowest x value, you can see it's right around negative 4, to here, which is the largest x value. So when you are looking for domain, you're looking for lowest x value to the highest x value. Now, how do I write that it's from negative 4 to positive 3, taking on all the values in between? First, observe the endpoints. At negative 4, we have a closed dot. At 3, we have a closed dot. And if you remember from that quick review we did of interval notation, when you have a closed dot, you put a square bracket next to that number. So this would be the way to specify the domain of this function. All the values from negative 4 up to 3, including negative 4 because of the square bracket, and including 3 because of the square bracket. Now, I'm going to go ahead and get rid of those. The range is the set of the outputs. It's the y coordinates. So now when I look at the graph, I want to look for the lowest y value, which is right about there, to the highest y value, which is right about there. Now, if I'm reading the y values, I'm reading to the y-axis. So you can see that the lowest value occurs at negative 1, and that is a closed dot down there, so that's going to be a square bracket. And the highest value is 6 when I read across to the y-axis, and it is a closed dot. So for the range, I'm going to record that as negative 1 to 6, and showing I'm including both those values by using square brackets. The x-intercept is where the graph crosses the x-axis. Here is where that is happening. This is the horizontal x-axis. It is crossing at the value negative 3. What is the x-intercept? I would choose choice A, and I would fill in x equals negative 3. Now, they only wanted the x coordinates, so I would only say negative 3. If they wanted the coordinates of that point, of course, you should be able to name that that is the point x is negative 3, y is 0. But that is not asked for in this case. For part D, we're looking for the y-intercept. So we're looking for the place on the y-axis where our function crosses. And you can see that occurs right there. I look at the y value that occurs at, which is 3. So what is the y-intercept? I would choose choice A. I would say y equals 3. And again, if I needed to write the coordinates of this point, the x value is 0 when the y value is 3. The last thing we're supposed to do, and I know it appears at the bottom of the screen, but you can also see it up here at the top. This is letter E. Evaluate the function f of negative 2. We just did this algebraically when the rule for the function was specified. When all that you have is the actual graph, take a look at what's inside the parentheses. That is your input, that is your x value. You go to the graph, you find that x value, you go up until you hit the graph, and then you read over to the y. So one more time, I start at negative 2 on the x-axis, I go up, hit the function, read across, and the y value I'm located at would be 1. That is my function value. Now here's question 3. I thought we would do one more of these, but this time instead of the graph having endpoints, you'll notice that the graph has arrows on each end of the function. So let's take a look at how that changes things. We're asked again to use the graph to determine the domain, the range, the x-intercept, the y-intercepts, and the function values. Domain means you're looking for the lowest x value and the highest x value, and then naming everything in between, because in this case, that's where the line shows up. Now don't be fooled. You may look at the edge of the graph and think, oh, the lowest x value on the graph is negative 6. But that wouldn't be correct, because we have an arrow here. And that does mean that this line continues in this direction off the graph. So if that's the case, it keeps going, 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 going. I can't name the smallest number because anytime I try to, I move a little to the left and there's a smaller number. When a function continues this way infinitely in one direction, we use the symbol infinity. Now, in this case, because it's infinity in the direction of the negative numbers, the proper lowest value to write for the domain would be negative infinity. Now, when you put an infinity symbol into interval notation, you always put a round bracket next to negative infinity. Kind of makes sense because what you're saying is you never really equal negative infinity. You just get closer and closer and closer to it. All right, now let's look at trying to locate the highest x value. Well, here's where it seems to stop on the graph. And you might say, oh, okay, I look down to the x-axis, my highest value is 6. But again, that wouldn't be correct because this graph is going to continue infinitely in this direction. And if that's the case, can I ever really say what the highest x value is? No, because I could always take another step to the right and that x value would appear on this graph. So again, when you continue infinitely in one direction, we're going to say infinity. You can say positive infinity, but in most cases, we don't actually write the plus sign on the positive infinity. And again, always a round bracket. For part B, the range, we're trying to identify the lowest y value to the highest y value. Well, in this graph, if you look, it never goes lower than here. There's never a point that has a y coordinate of 3 or 2 or 1. So 4 is definitely my lowest y value. Now, do I use a round or square bracket? All of these points here exist. We don't usually draw them, but if we did, we would draw them as closed dots, and those dots connected make the line. Therefore, we're going to put a square bracket next to the 4. Then we go looking for the highest y value. So I might go up here and say, oh, right there. However, keep in mind, once again, we have one of these pesky arrows. The arrow means this graph will continue in this direction. If that's its behavior, you will never be able to say what the highest y value will be because it's going to keep going and going. If it keeps going infinitely, you just have to decide, is it heading towards positive infinity or negative infinity? And just look at the numbers on that part of the axis. 4 to infinity, round bracket next to infinity, always. The next thing that we are asked to find are the x-intercepts. So I scan along the x-axis. There's no blue there. The function always is up here and never crosses the x-axis. Therefore, choice B would be correct. There is no x-intercept. If I'm looking for the y-intercept, I'm looking along the y-axis. And yes, blue does cross the y-axis. In other words, the function crosses the y-axis at 4. So in this case, the intercept would be. All right, and once again, part E is down at the bottom of the screen. However, we can also see it up here. We're looking for 2 particular function values this time. The first one I want to locate is at an input of -3. Inputs are on the x-axis. I read up to the graph. Then I read over to the y-axis. It hits the number 4, so 4 is the output. I repeat the process now with an input of 1. I go to 1, go up to my function, go across to the axis, and I'm at 5.